What is Euler's number, and where does it come from? Euler's number is designated by the letter E and has the value 2.71828, and it keeps on going forever. In fact, Euler's number is irrational, meaning that it can't be constructed from a ratio of two integers. It also means that series of numbers won't cycle or repeat. It's a truly unique infinite decimal expansion. In fact, because of that, it's not possible to actually write down this number. There are other irrational numbers too, and you might have heard of another famous one called pi. We'll see later that there is in fact a connection between Euler's number and pi. In the case of Euler's number, it can be derived in many different ways. However, we'll define it in its natural form graphically. Let's look at the simple reciprocal function y is equal to 1 divided by t. You'll notice that as t increases, the value y decreases. Let's start by increasing t, starting from the position where t equals 1. So we're moving right along the t-axis. Notice that in addition to increasing t, as we move right, we're also increasing the surface area underneath the graph. We can stop at the position of t that makes that surface area under the curve exactly equal to 1. When this happens, t ends up being equal to Euler's number, E. Why did we do all of this? We won't get into the details, but it's worth mentioning that this area under a curve is something that we can compute using an integral from calculus. When we integrate our simple reciprocal function, it produces another very useful function called a logarithm. So there's a reason behind all of this work.